So before we start logarithm rules, I want to talk about exponent properties or exponent rules. The very first rule that deals with exponents is if I have two exponents that share a common base, how can I put together those exponents? I add them. So if I have x cubed times x to the fourth, I can add those exponents, and that gives me x to the seventh. Does that make sense to everybody? So if you have two bases, you add exponents. So multiplying two bases, we add the exponents. Here is an example in Calculus 1 where you will use this rule. Are you ready? Here's one example right here. So for example, suppose I want to write this as a fractional exponent. Suppose I have the following. 1 over, and let's say I have x cubed times the square root of x. Suppose I'm looking at 1 over x cubed times the square root of x. Are y'all with me? So I will be employing something called the addition property when you have two like bases as part of this rule, but it's just a little piece of this rule. I have a base here and a base here, so I'm going to put those two together. So I have some other stuff I have to do before I even put them together. The first thing I have to do is I have to know how to change square root of x into having an exponent. Do you guys know what x square root of x is? It's x to a power. Do you guys know what power that is? Megan, what is that power actually? 1/2. So I don't know if you recall or remember, but roots are considered to be fractional exponents. So if you have a square root of x, that is equal to x to the 1/2 power. If I have a fifth root of x, that's considered to be x to the 1/5 power. So the nth root of x is considered to be x to the 1 over n. So that's a definition that somewhere in your notes should go because that is really powerful. So I did not write that down as another exponent rule, but I will just put that on the side that the nth root of x is called a fractional exponent, and that's x to the 1/n power. So that's the one that would put those together. Now, once I have x cubed times x to the 1/2, do you guys see now that I have two bases? Are you with me? So what do I do to put those exponents together? I have to add them. Abel, can you add for me 3.5 and tell me what exponent I get when I take 3.5? Like, get me a fractional exponent out of that. That's x to the, 3 plus 1/2. Oh, I better do a little thinking, right? That's 3 plus 1/2, which is 3.5. Or what do you get for that guy? 7/2? Is that what you get? I get 7/2. So I see this as 1 over x to the 7/2. How are you guys? Okay? Now, you could leave it like this because I didn't say anything else, but I could also think of it as x to a negative power, right? Because the negative power brings you down. And so I could also think of it as x to the negative 7/2. Being able to use this very first rule here, where you have like bases, you add your exponents, becomes critical in Calculus 1. Because we are doing places where you have to take this and rewrite it like this. Okay? So that is something really important. The second rule that becomes very important is instead of multiplying like bases, the second rule that I would consider most important with exponents is when you're dividing like bases. So for instance, if I have x to the 8th over, let's just say, x squared. So instead of multiplying like bases, it's when I divide like bases. And what is that going to give us? Evan, do you remember how to do those? If you have x to the 8th over x squared? Yep, subtract. So what's that give you? X to the 6th. So for those, you would subtract the exponents. So let me erase this. So that would be 8 minus 2. And so that would be x to the 6th. So that becomes the second place. So that is, if you're dividing like bases, we subtract exponents. And then there's one more rule. And that's when you have a power to a power. An example of a power to a power would be, what if you have x raised to the 3/5 squared? What do you do when you have a power raised to a power? What do you do? Do you guys know? Katya, do you know what you do? You multiply those exponents. So if you have a power raised to a power, so in this case, notice you have 1x only, but 2 powers, but you still have 1x only. So if you are raising a power to a power, we multiply the exponents. So that means if I have x to the 3/5 squared, what I'm really doing is taking x to the 3/5 times 2 over 1, which is just x to the 6/5. And that's another skill you need to have very handy when you get into calculus. We assume that you guys have these basic rules already, like knocked down. So when you have like bases, you add exponents. When they're on top of each other, you subtract exponents. And when you have a power to a power, you're simply multiplying exponents, okay? So those are 3 rules that are really critical when you get into calculus. So those are our 3 critical exponent rules. But I want to now apply those rules to logarithms, the correspondence between the two. So on your worksheet, you've got 4 different rules that are logarithm rules, okay? The first one says, if I have a log base b of m times n, what does that equal? If I have a log base b of m over n, what does that equal? If I have a log base b of b to a power, what does that equal? If I have a log base b raised to the log base b of m, what does that equal? So there's one more rule we really should have in here. But I'll get to that after. I'll get to that after. I'll do that after. I see I don't put it on here. I should have put it on here. I'll put that in a minute. But first of all, we're going to do the product rule. Log base b of m times n. An example would be the following. Suppose I have the log of, let's just say I have the log of, let's say 28. And I want to rewrite that into smaller logarithms. One way to do it is to observe that it's a product. And does anybody know the logarithm rule? If you have a product inside a logarithm, what you can do to expand that by any chance? So the rule is this. You can take the log base b of one times the log base b of the other. It kind of reverses that exponent rule. Do you remember the exponent? Remember, logarithms are exponents. So we said that if we have 2 bases and we have multiplied together, what do we do to our exponents? We add them. It's kind of the same idea what's happening here. We've got 2 things multiplied, so we break them up into single logarithms and they're being added. I can go through the whole proof with you, but I think I just want to stop there and say, so one way that we can rewrite log of 28, one way that we could rewrite it is we could rewrite it as, well, let me just put an x in here just to do something. So we could rewrite that as the log of 28 plus the log of x. Let me erase and put 28x inside instead of just 28. But I could also have done anything, really. If I had just 28 in here, I could rewrite that as the log of 18 plus the log of 10. It's pretty cool. You could check it on your calculator. Or the log of 20 plus the log of 8. You know what I mean? It would be really cool if you tried that out. But if you have a product inside, you can break that up as the sum of the two elements. Oh, I did that wrong. Not 18 and 10. Hang on, Tina. You're being stupid right now. You're being stupid and trying to go too fast. Sorry. What two numbers could I put in there? So they have to make a product to 28. 7 and 4. 2 and 14. Yeah, my bad. Yep. All right, the second rule is called the quotient rule. The quotient rule is just like the product rule, except if you have a log of a number divided by a number, you can separate those logs by subtraction. So, for example, if I have the log of x cubed plus 3 over x squared minus 7, I can rewrite this as the log of x cubed plus 3 minus the log of x squared minus 7. So you can break up logarithms when they have a quotient by subtracting those logarithms. So that's also possible. That is also true. The next rule is called the inverse rule, and we actually talked about this last time. Evan, you were here last time?
Yeah.
So do you remember if we have a logarithm and then an exponent, they're inverse functions of each other, right? So if we apply a logarithm to an exponent, what should we get back? We should just get back the thing we started with, which is just going to be, for this example, p. Because they cancel each other out, remember?
Right.
Do you remember that?
Yeah.
So, for example, suppose I have the log, nope, let's undo it. Let's do the natural log of the e function to the 5. That is just going to be 5 because the natural log and the exponential function are inverse functions of each other. The natural log is log base e, and so the log base e of e to the 5th is just 5. They're inverse operations. So the idea is, notice that a logarithm and an exponential functions are inverses of each other, as long as the b values match. And that's also what happens down here when you look at this inverse. Again, you have an exponent, and then you have a logarithm, and you can cancel them out and just get the value m back inside. So maybe you'll see 3 raised to the log base 3 of x. The 3 and the log base 3 are inverse operations, and so you'll just get x back. There's one more rule I forgot to put on here, which is extremely powerful and is used all the time in calculus as well. That's called the power rule. And the power rule is as follows. The log base b of m to the p is p times the log base b of m. The log base b of m to the p equals p times the log base b of m. Another rule that we just memorize, okay? It's just a rule that we memorize. I can show you where they all come from, but sometimes just memorizing them is easier. An example of where this would come into play is if I had something like this. I had 1/3 logarithm of 4x. I can rewrite that logarithm as the log base 4 of the cubed root of x, or x to the 1/3 power. So those guys would be equivalent because the 1/3 could come up as a power, I know that a fractional exponent can turn into a radical. So 1/3 log base 4 of x could become log base 4 of the cubed root of x. And the intermediate step would be log base 4 of x raised to the 1/3 power. Again, this comes up in calculus, so I want to make sure we have all these rules. So I want to make sure, because I gave you guys a piece of paper, does everybody got those rules written down? Does everybody have those rules written down? We want to spend some time getting used to these rules. So I have several examples, example 1 and example 2. We want to just focus on those to start with. Example 1 says you have 2 logarithms. You want to, what do we want to do this? Use the logarithms to find the exact value of each expression without using a calculator. So those guys, you want to use your properties to rewrite them so you get an exact value without a calculator. And then the bottom one, what you want to do is rewrite those logarithms so they're separated into parts. So the second piece is you want to use your rules to break up things and rewrite them and expand them into simpler parts. Okay? So the first one is to rewrite so that you can evaluate without a calculator, and the second one is to write them as sums or differences of logarithms, okay? Sums or difference of logarithms. And if you're not quite clear on the instructions, let me know, okay? If you're not quite clear on the instructions, let me know. So, if you have a sum, which rule does that apply to? So, put them together by doing what? Yep. Can you do that without a calculator? What's your base? Understood. Beautiful. Oh, so cool. Very, very good, very good. Yes, you do, because you just did these. Did you do them in your head? You're just doing these in your head, right? Yeah, so you did this guy, so I know you did that. Oh, and one more thing, there's a minus. What do you do with the balance? Oh, yeah. How are you? Definitely, how are you? Ooh. So, 10 to the what gives you 5. 10 to the what gives you 2. So you want to put these together using one of these rules. Okay? You want to put these together using one of these rules. Which rule do you want to use? So put them together. 5 times 2, right? That's 5 times 2. What is the log of 10? Do you know how you got this one? There you go. Evan, how are you doing?
We're coming around.
Oh, yeah.
Figure out this, the 9 in the front.
Now, when you're adding them up, what are you supposed to do with the numbers inside?
You're supposed to multiply them.
And what did you do?
Oh, shoot.
You see?
Yeah, it's a 10.
Yeah. we supposed to do to them? Multiply them. Good, beautiful. So it's log of. Beautiful. And what is the log of 10?
Or is it?
What is the log of 10? 1. Ooh, we're getting close. Now you have a log base 5. Don't lose your log base 5, right? Don't lose your log base 5. How are you? Let's see. Good. Nice. I would put parentheses around this guy. And this guy you could separate into two separate as a sum or difference. That's what I would do there. Okay, let's talk about these. Let's see what we're talking about here. Good. Now, don't forget you have a log base 5 in front. Log base 5. Okay, guys, let's see these logarithm rules. It's hard to start learning. You have to practice a lot with the logarithm rules. So if you have two logarithms, we can combine two logarithms into one logarithm using the rule. And the rule says if you have two logarithms that are added, you multiply those values to get them into a single logarithm. So you would be multiplying those values. In other words, you're looking for the log of 10. And that's easy because the question is 10 to what gives you 10? That's the question you ask, and that's easy, so that answer is just 1. So that first logarithm, I'm telling you, you guys should be able to do this like this. There's no, we should be able to get really good at seeing these and just working these through. The second one, if I have two logarithms and they're joined with a subtraction, what did you get for that one, Evan? It's log base 5 of 75 divided by 3, because we're dividing those. So it's log base 5 of 25. And what is the log base 5 of 25? 2. Absolutely. So this answer should be 2. Guys, okay? And that last one, Ella, what did you do for that one? You just did what? You
Use the
inverse rule. You have an exponential and a logarithm of the same base. So the answer is just 21. Perfect. Okay, good. Any questions on those three? All right, Mason, help me out here. I've got a log base 3, and inside I have a quotient, right? How do I break up quotients into bigger? So now I want to break this up into two logarithms because it says write this as a sum or difference. So what would I do? I want to break these up. So I have a quotient, right? I want to break it up into smaller pieces. So what do I want to do? I want to write the log base 3 of You know what to do? Okay, so hang on. No, seriously, hang on 1 second, Mason. Are you with me? This is a rule. Okay? I can tell you why it's true, but this is a rule. It's like you obey this rule. If you have two logarithms with the same base and they're being subtracted, you can put them together into one logarithm, but what do you have to do with those objects inside? We have to divide them. We have to divide them. You see, subtraction makes division. If they're added, I have to multiply them. Are you with me? So, if they're together down here as a division, and I want to separate them into two parts, am I going to add or subtract them? Subtract them. Beautiful. Now, my base stays 3, so which guy goes first? Log base 3 of 2, and then minus log base 3 of x plus 5. So this would be a difference of two logarithms where they're being subtracted by that rule. All right. Okay, who wants to help me out on this one? So this is a log of a cubed root. Ooh, Megan, what's my exponent if it's a cubed root? That would be 1/3. 1/3. Okay, good. So I have a 1/3 exponent. cubed roots turn into fractional exponents 1/3. Now, I can't break it up yet. The reason I can't break it up is because this is still inside a power. So I first have to move my power down. Katya, did you move your power down first? And what did you get? And that's using the power rule right here, right? Power rule says I can take my power and do what with it? Bring it in front. So tell me what you wrote.
1/3 log of x plus 1 squared.
Yep, x plus 1 squared, x squared plus 1 plus x squared. Beautiful. And did you break it up then? Good. Into two smaller logarithms, right? Now that 1/3, I'm just going to put that 1/3's on the whole thing, just to remind us all. So that 1/3 stays on the outside of whatever I'm going to now do, which is break up this log. And Mason, I'm just going to show you. You got a product in here, right? So this time, instead of subtracting, what are we going to do? We're going to add them. Katya, what did you put here? So you have the
1/3 times log of x
Uh-huh.
plus log of 1 plus x squared.
Good. And so you could stop right there, or if you wanted to, you could distribute and write it as 1/3 log of x plus 1/3 log of 1 plus x squared. I'm not sure what they're going to require in your homework on My Open Math, but that would work for either of those. Who has a question? Right here. You can take that power and bring him down to the front. Okay? So on your homework, it's going to tell you, if you have a single logarithm and you're expanding it out, you want to take that power and put it down to the front. That's exactly what you want to do. And this guy over here, I'll just go through it quick. 64x to the 5th. Because I have a product inside, I want to expand it as a sum. So I have log base 8 of 64, log base 8 of x to the 5th. And Megan, you'll get the same answer I get. Because the log base 8 of 64 is 8 to the what is 64. 8 to the what is 64, that's just 2. And this one, the only thing I can do is bring that 5 down to the front. And so I have 2 plus 5 log base 8. This guy is beautiful. And on this one, before you add up your logarithms, you have to use that logarithm rule and bring it up front. So in this one, it says write as a single log. If you write as a single log, you want to put it together to have a single log. And if they're separated by a plus, well, then you have to put them together with a product. And when you put those products together, that 4 would only apply to that second quantity. So it only applies to that x minus 1. So when you put them together, that's what you get. And I'm just going to keep wandering. I need 2 people to do those last 2 because those are kind of funky and tricky. Who wants to do those last 2? Write that up there for me on the iPad. That one looks beautiful. Well, single log right here, right? So not all the extra logs. Beautiful. On top of that, minus, which is divided by that, plus that. And so what I am going to show you, and there's this quick rule about this guy. What happened was right here, we added them before we subtracted. So the quick rule is if it has a negative in front of the log, it's on the denominator, and it's a positive in front, then it's a numerator. So, do you see that? Yeah, kind of, because that creates a negative exponent, which brings it to the denominator. So the only ones that'll be on the bottom are these 2, and those 2 will be on the top. Okay? How you doing? Put those together for me, Evan, right? Bring the powers up. Bring the power up. Bring the power up first.
So I can put it, so I don't drag it all the way down.
No, this 2 goes on this 6x cubed
Wow.
because of the power rule. This rule right here. These are new rules which you might not have ever done before. I can show you why but mathematically it gets confusing. Your job is to just memorize these rules. So you bring the p down to the front.
Okay.
It's just a property. Or you bring the p up.
So I'll move that 2.
Nope, not that one. If you have you see how that guy's in
Yeah.
front? He is in front. You can bring him up here as a power.
Oh, so I'd rewrite it as 2x plus log 2x minus 1, and then add the 4 here.
Yep, all to the power 4. Yep.
So all of this.
Nope, only this is to the power 4.
Oh, so just.
Yep.
that.
Okay. Now, that is this rule right here. Now you have 2 separate logarithms.
Yeah.
They're being added. You can put them together with a quotient. Abel, did you get that last one? Did you get the last one? I don't think I had you write one up there for me yet. Very close. Very close. Very close. So this guy would be on top because it's on top. He would be on top because he's first. So he's positive. He stays on top. So he stays on top. The other 2 stay on the bottom and then multiply. Yeah. I'll write this. I'll write this last one out. This last one is really tricky. Oh, beautiful. Beautiful, 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 beautiful. This last one is extra tricky. On the last one, my first step, because it's a big, long string, there's a couple ways you could look at it. One way is you could take, first of all, any power goes on top, up here. If you like, you really could take and put those powers on top of in front. If you like, you could always bring that negative up top, but students don't always like to bring that negative up. But you could bring the negative up if you wanted to, if that helps you understand a little better. This negative is in front, and so what really is happening is you have a logarithm raised to the x plus 1 raised to the negative 1. And then this one here is a logarithm of x to the 8th power. So what happens is, whenever you have powers in front, you can bring them up top. If there's a negative, you really could think of it as something to the negative 1. It's up to you. If you have a big, long string, that might be easier. And when you put your logarithms together, if they're added, you're multiplying everything. So really, here's one way to look at it. You're multiplying everything. So it's 4 minus x squared to the 3rd power times x minus 1 to the x minus 3 to the negative 1 power times x plus 1 to the negative 1 power times x to the 8th. And these guys are both negative, which means they have to go down to the denominator. So if you guys are putting it all together, you would get that 4x minus squared is raised to the 3rd, and that's on top. X to the 8th is also on top. And the other 2 factors, x minus 3 and x plus 1, are down in the denominator. That will give you a single logarithm with all of those powers. There's a lot of ways to do it. If I see a negative in front of my logarithm, I know that has to go to the denominator. If I see a negative in front of a logarithm, I know he has to go to the denominator. If there's a plus in front, I know he's going to be on the top. He's a positive, he's on the top. So there's a lot of ways to look at that when you combine these logarithms. Students don't like logarithms because logarithms are exponents, and to solve these logarithm rules, it's really quite, it's a lot of play on algebra. And so you want to get used to just memorizing. I don't care how you memorize it. Log of A times B is the log of A plus the log of B. Just got to memorize it, right? The log of A divided by B is log of A minus log of B. The log of A to a power is a power times the log of A. You just kind of got to get these memorized. Those are the three big rules. And when you get into calculus, you have to start taking derivatives and all kinds of funky things. So you have to have those three rules solidified down. So practice, okay guys, practice. I'm gonna stop early because I don't want to give you any more stuff. Well, we're not stopping that early, just 6 minutes early. But I want you guys to take some time to try and some of your homework if you have time. We did not finish the last page. The last page we can go through. You can use calculators. You're using a calculator for a lot of those on the last page. We did talk about that last example. Oh, let me just put this down in the notes for people that weren't here in case you're doing your homework. We did this last time. Last time in our calculators, we actually computed values. And so on the last page, I do just want to write this down, the change of base formula. So if you weren't here last time, if you are trying to use a calculator to evaluate something like this, log base 5 of 15 or log base 5 of 16 or something, your calculator doesn't have a base 5. It does have a logarithm button and a natural logarithm button. And so you could use the change of base formula to get the value. You can always take the log of 16 over the log of 5. So that's called your change of base formula. But we'll talk more about logarithms next time. Okay, guys, we'll talk a little bit more about logarithms next time.